Welcome. There is a gate question 2022. Okay, gate question 2022 for 2 marks to design of steel members. The question is here: a weld is used for joining an angle section ISA. You can see in the figure. ISA angle section is there like this, 100 by 100 by 10 mm thick to a gusset plate. So there is a plate here for gusset plate. You can see in the figure of thickness 15 mm. To transmit a tensile load. The permissible stress in the angle is about 150 megapascals and the permissible shear stress on the section through the throat of the fillet well is 0.8 so is 108 megapascal. The location of centroid of the angle is represented by CYY. You can see in the figure here. So CYY is given from the steel table, that is 28.4 mm. The area of cross section of the angle is 1903 mm square. It's from steel table only. Assuming the effective throat thickness of the weld is 0.7 times, okay, 0.7 times the given weld size. The length L1 and L2 of the weld required to transmit a load equal to full strength of transmission tension, full strength of tension member. So the L1 and L2 of the weld are required to transmit a load equal to the full strength of the tension member are representatively. Okay, so you have to round off to the nearest value. Now there are many numericals are there. So let's write the values one by one in detail. So from the given data, if you see properly, permissible shear stress, okay, shear stress of the section through the throat of fillet weld is given as how much? 108 megapascal. So permissible shear stress is given, and next is permissible stress in the angle. So permissible stress, okay, dot shear stress in angle. Angle is how much? 150 megapascals. These two 108 megapascal, 150 megapascals are given in the data only. And centroid of the angle member is CYY. So the CYY value is also given how much? 28.4 that is CYY. And area of cross section, so AC is also given, area of cross section 1903 mm square. So this value and this megapascals are from your steel table. Now one second. Yeah, now let me calculate strength of the section. So let me find the strength of section. To find strength of section, we have formula. So permissible stress, that is 150 into area of the angle, okay, into cross-sectional area of the angle, that is 1903. So 150 into 1903 is 285.45 kilonewtons, okay, 285.45 kilonewtons. Effective size of weld, okay, effective size of weld. So if weld is given as 0.7 times of, okay, 0.7 times of the where is 5 weld size, okay, 0.7 times of the weld size. So weld size is 5 mm weld is given in the figure, you can see here. So 0.7 into 5, that is 3.5 mm. Okay, please note up to here. Next, next 3.5 mm is there. Area of the weld required. Now what is the area of the weld required? So we have formula here, area of weld required, how much? So it is 285.450, that is strength of the section by 108. Area of weld required is 285.450 by 108 is 2643.055 meter square. So area na, so meter square. area of weld required is 2643.05 mm square. Now length of weld required. So length of weld required, but it will be your L1 plus L2. So length of weld L1 plus L2 is equal to 2 area of the weld required 2643.055 by 3.5. If you want to find length of the weld required, so 3.5 is the effective size of the weld. So total area of the weld required by effective size of the weld required is, you get the value of length of the weld required, that is 755.158 mm. Now we are saying length of the weld required L1 by L1 plus L2. Okay, please note up to here. Now if I write like this, length of weld L1 by L2 is equal to 71 angle section 71.6 by 28.4, that is 2.52 meters. But we know that L1 plus L2 is equal to 755.158 mm. Okay, so from here I write here L1 is equal to 2.52 L2. So I write here 2.52 L2 plus L2 is equal to 755.158. That is, if I take L2 common, I get here 3.52 L2 is equal to 755.158. So therefore L2 is equal to 755.158 mm by 3.52, because L1 plus L2 is equal to this value. I want L2 now substituting here, because L1 is equal, if you take ratio, L1 is equal to 2.52 into L2 cross multiplication. So substitute 2.52 here in place of L2. Okay, L1 is equal to 2.52 L2. In place of L1, substitute here 2.52 L2. So 2.52 L2 plus L2 is 3.52 L2. So 3.52 L2 is equal to 755.158. Therefore L2 is equal to 755.158 by 3.52. Therefore L2 is 214. How much? 214.53 mm. So if you want to round up to its nearest integer, that is 214. Okay, so my L2 is 214, and substitute and for the substitution, my L1 will be 514 mm. So for this problem, option A is the correct answer. Thank you. Problem is solved. There is one more gate question 2022 for 1 mark from steel members. For a square steel beam cross section shown in figure, the shape factor about ZZ axis is S and plastic moment capacity is MP. Consider yield stress Fi is 250 megapascals and side A is 100 mm. The value of S and MP round off to 1 decimal place R. So first understand the figure. Here K, J, I and H are the corners of a square steel beam. Okay, and the Z axis is there. So distance. So if you take this horizontal line like this, or you take a draw a line here and draw a line here. Okay, this is the total depth of the section. So this is root 2a. Okay, this value is root 2a, and the half of this up to here, the center is C or O. This value is root 2 by 2a. This is root 2a. This is root 2 by 2a. Please remember these parameters. Okay, we take these type of numbers. The total depth from K to I is root 2a, and K to center of the square block is root 2 by 2a. Okay, so now for this case, shape factor. Okay, the shape factor for this type of steel cross beam is considered as 2. Okay, we have 2 decimals here. 2 values are there in options 2 and 2. Let us find the MP, that is plastic moment capacity. So to find the shape factor, we have formula shape factor is equal to plastic moment by elastic moment. So plastic moment is MP by elastic moment is My. Okay, so plastic moment by elastic moment. Now again we can write here shape factor is equal to Fi into ZP, sorry, Fi into ZP Fy into ZP, that is plastic moment, by again Fy into MP, sorry, Fy into ZD. 1 second. ZP by ZD activities. ZP by ZD elastic moment. So shear factor is equal to plastic moment by plastic moment. So Fy into ZP plastic moment by Fy by into ZD elastic moment. So I want plastic moment from MP. So from here I want MP here. So MP is equal to S into Fy into ZD. That is S is 2, Fy is 250 into ZD. So ZD is taken as, okay, root 2 into A cube, 100 cube by 12 into 10 power minus 6. So root 2, sorry, 2 into 250 into root 2 into 100 cube by 12 into 10 power minus 6. Here my answer is 58.93 kilonewton meter. So if you observe carefully, I have two shear factor values 2 and 2, and 589.3 azimuth is almost option A. For this type of problems, option A is the correct value. Problem is solved. Thank you.